Hi, I'm going to show you the simulation result, which is I cropped from the simulation window, where you can see that it's going uh, up when the up counter is up down is high, then it going up, and when up is low, and then it's going down. You can see that it will jump to second floor, and when next floor is 3, then after next clock edge it will go to floor 3, and then so on it floor 4, and once it stop or here, and then if user press down floor, suppose down floor 2, then it will go from 4 to 3 and then 2, right? And if next floor is 1, then after one clock cycle it will be in floor 1. And when you can observe that the up down counter is active low when it's elevator going downward, and once it stop, and if elevator up down is high, then it will go high for floor 1 to 2, 3 and 4 and so on until you stop. Okay, now I will show you the code in the simulation test bench of this code, the elevator code. This is the elevator code, where you can see the clock, reset, stop, up, down, and floor, and next floor, and the floors are floor 1, 2, 3 and 4. States are floor types are the states. So you can see that if reset is 1, at the initial state it will be at the floor 1 state, and at the rising edge of clock, if and stop is 0. If stop is 1, then it will stop at that point. If stop is 0, then for the case floor state will assign over here when at the floor is 1, then the floor state at the floor is 1 when floor state is at floor 1, and floor value will be 2 when floor state at floor 2, floor value is 3 when floor state at floor 3, floor value is 4 when floor state is at floor 4, and by default case it will be at floor 1. So the floor cases are displayed over here. This is the case statement for the finite state machine. It is the machine logic. So when at floor 1, and if the up down counter is high and stop is 0, then it will go to floor 2, and otherwise in one of both case is invalid, then it will remain at the state floor 1. Either up down counter is low or and stop is 1, then it will be it will remain at state 1 at floor 1. For example, when up down is 1 and stop is 0, then it will go to floor 2, and at floor 2, if up down is 1 and stop 0, it will not stop over here because stop condition is 0, so it will be floor 3. There is another case when the up down counter is low and still stop is 0, then it will go at floor 1. In any other case, it will remain at floor 2. Similarly, in floor 3, there are 3 cases. One, when down counter is 0 and stop counter is 0, then it will go back to floor 2. Else, if the down counter is high and stop is 0, then it will go to higher portion, higher floor. In the other case, it will remain at floor 3. When floor is 4 is the max floor, then there is only one condition. Either floor up down will be 0 and stop is 0, then it will go to down floor, which is floor 3. Otherwise, it will remain at floor 4. So these are the other condition for the next floor. Next floor is 1 when the floor state is at floor 1 and stop is 1. In any case when the stop is 1, it will remain at the current state, right? Current state is floor 1, then it will remain at floor 1. Else when value next floor will assign to the floor 2 in case when the current state is 2 and stop is 1. In this case, next state will be floor 2. And you can see there other two cases for floor 2. You can see that the when current state is the floor 1 and up condition is high, then it will go to floor 2. Next floor is floor 2 for this condition. If stop is 0, up down is high, and current floor is floor 1, then it will go to up floor, which is floor 2, right? And the other condition is when the current state is floor 3 and the up down is low, then and stop is 0, then it can come back to floor 2. If current is 3, up down is low, stop is low, then it will go to floor 2. Similarly, for the floor 3, you can see the 3 cases. For floor 4, you can see the 3 cases. So I will show you how you can run this project. To demonstrate you, I will just show you step by step. You can follow all steps. Okay, I will create a new project. New project in the same folder. I'm going to create in this folder, right? Name of project is project 1, and I will not going to add any file right now. Okay, now I will add the file, and this is the module file. I'm going to add this file. Okay, yeah, this is the file I showed you. Okay, in simulation there is no testbench file. Now I'm going to add the simulation sources and add this file, this _tb file. Okay, you can see this file will instantiate inside the testbench file. Okay. Okay, the module name is emulators control under system. So here module name is slightly different. So I will just update the module name by copy pasting. Okay, you'll see that this is under this test bench. Okay, in the test bench you can see that this is the just declaration. This is the declaration for the test bench module, and this is the called module, and this is the mapping of signal, and here is the clock generator. It will generate the clock for 1000 nanosecond. You can change the time. Okay, then you can see the process. This is actually the condition to test. I will giving all these condition. You can see first of all in the reset mode, and the stop mode is 0, down counter is 0. After wait 20 nanosecond, reset is 0, for wait for 10 nanosecond, and up counter is high, then it will go high, and wait for 100 nanosecond and stop 1. In 100 nanosecond it will reach in a fourth state, and then it will stop, and then down counter is low, then it will start to move downward, and upward it will move up and down. All these conditions you can change the values, and you can observe them simulation results. So I just saved it as I had changed little bit over here, so I had to save that. Now I will press the simulation. Oh, you can see the simulation result. There is the state floor state is missing over here. I will just add to this floor and then go back to reset state, reset the simulation, and then just save. If you want to save your waveform, and I just save it. Okay, then play. Oh, you can see that it's run for 1000 nanosecond, right, as I shown you. Okay, now you can observe that it start jumps to the next floor. You can see the it's currently at floor floor 1. If next floor is, if up down is high, if up down value is high, and it start move upward, it will jump to next floor 2 and floor 3, then next floor 3. This is the just condition. It will assign value after 1 clock cycle, right? So you can see that this value is assigning after at the clock edge, and current state is 0, 1, then 2, then 3, then 4, and it stop, and it's start going downward. If the next floor is 2, if user want from 4 to 2, then it will start going downward from 3 and then 2, and you can see that in this condition the up down is low because it's going downward, and if up down is high, it will move to upward. And here all the simulation results. So I hope you understand, because there is no clock, then the output will not update or here. So if you want a long-term trend, then you can just change the value to suppose 10,000. I will just re-simulate, relaunch the simulation. You'll see that it will run this simulation for 10,000 nanosecond. Now currently running for 1000, and it will simulate for 10,000 nanosecond.